All right, so you picked up two things. You picked up a bright green half sheet that has this reference sheet. We're going to look at some of these today, not all of them, okay? And, well, actually, I think we do end up looking at all of them today. But we'll come back and kind of refer to this later on. I just want you to go ahead and have it. All this stuff is also on your notes for you to refer to. So let's look at this. So we're going to start here. That little half sheet is going on page 112. This is going on page 113. Okay. And we're going to look at basic trig identities. This whole first set of stuff, you pretty much already know these. So the question is always this little half sheet, do I have to memorize all of these? The answer to that is no. The first few boxes you already know, so they're just done. And then the rest of the stuff kind of just comes with understanding it, and eventually you just know them, but no, you don't have to memorize them, okay? Because then all that is you just memorizing. So you will get this to refer to, but I don't even think you'll need it. So most of the time. It says a trigonometric identity is an equation involving trigonometric functions that is true for all values for which every expression in the equation is defined. Okay, that whole is defined is important because we know that tangent is sine over cosine. You've known that for a long time, but that's only true when cosine does not equal 0, right? Because you can't divide by 0. So that's the whole where it's defined, okay? It says the identities help evaluate functions, simplify expressions, and verify identities and solve equations. So we're going to learn how to manipulate some stuff that's going to lead into some other things that eventually leads into us actually solving equations with trig values in them. So these identities, I never used these words with you yet, but you already know these. The quotient, that's just dividing, right? You know that tangent is sine over cosine, and you know that cotangent is cosine over sine, yes? And then reciprocal identities, well, you know that sine is the reciprocal of cosecant, and cosine is the reciprocal of secant, and so forth and so on. So these things you already know, but they're just called reciprocal identities and quotient identities. There you go, okay? So this says use the quotient and reciprocal identities. Here's the key here, is that there are other ways to solve some of these, but we have to do by what it says on this first round through. That's to make sure we understand how to do this, and then later on you get to decide how you would handle it. But plus the way it's asking us to do it is actually going to be a little bit easier than what we might already have done with this stuff. So we're going to use the quotient and reciprocal identities to find each function value. So we know that secant of theta is negative square root of 30 over 3. We want to find the cosine of theta, right? Well, isn't secant just the reciprocal of cosine? Yes? That means that cosine theta is equal to the reciprocal of this fraction. So it would be negative 3 over the square root of 30. And then you just have to clean it up, right? I'd rationalize by multiplying by the square root of 30 over the square root of 30. So that's going to give me 3 square root of 30 over 30, and that's negative. And then can I reduce that? Yep, into negative square root of 30 over what? 10. So my cosine, and I can just put then that, instead of rewriting all of it, I can say that equals cosine theta. And we're done. So basically I just used the idea that those are reciprocals, and I figured out cosine. Easy enough? So let's look at using the quotient. Well, tangent of x is square root of 2 over 4, and I have the cosine. So I know that tangent of x is equal to sine of x over cosine x, right? We all agree with that one? So now I just substitute. Tangent of x is the square root of 2 over 4. That's equal to the sine, which I don't know, sine of x, over the cosine of x, which is negative 2 square root of 2 over 3. Now, listen very carefully here. There are multiple ways to get out of this fraction and a fraction mess, okay? Multiplying by the reciprocal is not one that I would suggest. The reason you would multiply by a reciprocal here would be to clean up this fraction. Does that make sense to you? I could also, bless you, I could also cross multiply. I wouldn't suggest that either. What I would suggest here is that we're trying to get sine of x, but we don't even care about x. We just want sine of x by itself, right? So instead, I would take sine of x as being divided by this. What's the opposite of division? Multiplication. So I'm going to multiply both sides by that fraction. not by the reciprocal. Okay, do you understand why I'm not using the reciprocal? I would use the reciprocal when I'm dividing the fraction. Like if I would multiply sine of x times the reciprocal to get all that in one thing. But that's not what I'm trying to do. I'm trying to move it. So no matter what this is, if this was sine of x over 3, then we would multiply both sides by 3. Y'all agree with that? Sine of x over a monkey, I'd multiply both sides by the monkey, right? So I'm multiplying by whatever's in the denominator. So when I multiply both sides by this, I get negative 2 square root of 2 over 3 times square root of 2 over 4 equals the sine of x. You only do the reciprocal, multiply by the reciprocal when you're dividing. And that's, I mean, I could have done that and cleaned that up, but it's just going to make everything weirder. Okay? Everybody with me so far? Did I lose you? No? Okay. So then in the numerator, what's the square root of 2 times the square root of 2? Square root of 2 times the square root of 2 is 2 times 2 is 4, right? So this all divides out with that 4. And am I just left with negative 3? No, what am I left with? Negative 1/3. You have to be careful. Doesn't jump out of the denominator. Okay. Any questions? Ask me questions if you got them. Okay, so I kind of skipped a step. Let me back up and let me write this step in there. I have the negative squared, well, let me write it correctly though. I have negative 2 square root of 2 times the square root of 2, like this, right? Okay, so if we know that 2 times the square root of 2 times the square root of 2 is 2. So I get negative 2 times 2 over 3 times 4, right? And 2 times 2 is 4, and it knocks out that 4. You good so far? And that's why you're left with that 1/3, because you're left with a 1 up there. Okay, I just sort of skipped through some steps, which you may or may not want to do. If you're not going to get lost in your numbers, it's fine. Okay, we good? Okay. So let's look at number 3. I've got the cosecant of beta and the cotangent of beta, and I want to find the secant of beta. All right, well, here's what I know about the cotangent. I know that the cotangent of beta is equal to cosine over sine. Well, I don't have cosine or sine, right? But cosecant is the reciprocal of what? Sine. So I can make this sine of beta is equal to 3/7. Right? It's just the reciprocal of it. And then I can use the sine and the cotangent to find cosine, and then cosine can lead me to secant. Does that make sense to you? If I can figure out what the cosine is, I can just take the reciprocal and I'll get the secant that I actually want. Everybody with me so far? So now I have this. I have figured out what the sine is based on what they gave me. I'm going to substitute. So cotangent is negative 2 square root of 10 over 3. I'm just using this and substituting. And that's equal to the cosine, which I don't know, over the sine, which is 3/7. So cotangent equals cosine over sine. Everybody with me? So I'm going to multiply both sides by what? 3/7. So this is going to give me 3/7 times negative 2 square root of 10 over 3 equals the cosine of beta. Can I reduce before I multiply here? The 3's, yes. So I get that the cosine of beta is equal to negative 2 square root of 10 over 7. Am I done? No, because they didn't ask me for cosine. Asked me for secant, which is the reciprocal. So the secant of beta is equal to 7 over negative 2 square root of 10. Not done, because I can't have the square root in the denominator, right? So I multiply by the square root of 10 over the square root of 10, and I get 7 square root of 10 over 20, and it is negative. You have to have organized work. It's not about having neat handwriting. It's about having your work organized where you can follow it and other people can follow it. And you can find your stuff inside of there, and it's labeled correctly. So you're using the right pieces. Any questions at all? Okay. We good? What are you looking at? They can't read this. These are zeros and they look funny. I don't know if that's what you're trying to look. 20, because I did square root of 10 times the square root of 10 is 10 times 2 is 20. It's still negative, yeah. It's because there was a negative sign on it. Yeah. Okay, we good? Anything? All right, so let's talk about some new identities that we have. They're called the Pythagorean Identities, and they're going to make total sense to you, because watch what happens. If I have a triangle in the coordinate plane, right, here's just something that it belongs in the unit circle, right? So the unit circle is around here somewhere like so. Okay? Then on the unit circle, your x value is what? What's the x value on the unit circle? Is it sine or cosine? Cosine. So cosine theta, that is your x value, right? Your y value is the sine of theta. If it is the unit circle, then your hypotenuse is what? 1. Not tangent. It's 1. All right, so does this look right? Does this sound familiar? Have you ever heard of the Pythagorean theorem? Yes, you have, right? So guess what? A squared plus b squared equals c squared. So cosine squared plus sine squared equals 1 squared. Does that make sense to you? It's just from the Pythagorean theorem. That's your first identity right there. The other identities come from that same thing, just substituting in the quotients and the reciprocals and whatnot. But it all just comes, that's why they're called the Pythagorean Identities. It's like the Pythagorean theorem. So that's it. Okay? Easy enough? But remember, you don't have to have it memorized. This one, really you should, and it's going to come up so much you just will. But you may need to refer to something to make sure you keep these straight, and that's understandable. Okay? So let's look at what happens. It says use the Pythagorean identities to find each function value. So again, I have to do that with Pythagorean identities. And I'm looking for cosine and tangent. So I'm probably going to have to do it twice. I'm given sine, and I'm told that cotangent of theta is less than 0. So what quadrant we're in is important here. If sine is negative, sine is only negative in which quadrants? 3 and 4, right? And cotangent is negative. Cotangent is negative in 2nd and 4th, right? So they overlap here, so this means we're in the 4th quadrant for both of those things to be true. Does that make sense? That matters because I'm looking for the cosine and the tangent. Well, if I'm in quadrant 4, is cosine going to be positive or negative? It's 4th quadrant, it's positive, and tangent is negative, okay? Because we're doing Pythagorean theorem, basically, which means we're going to take the square root. And when you take a square root, you get plus or minus. And so that's how you know which one to choose, is what quadrant we're in. That's why the quadrant matters. Okay? So let's look at how this works. We're going to find cosine first. And I have sine, so I'm going to use this. So I'm going to use cosine squared. Oh, the other thing I needed to tell you is this. When we do square these, like if I say cosine of theta and I want to square it, the way you write it is this way. You are not distributing the squares. Theta does not get squared. It's the cosine value that gets squared. That's why it's written this way. Okay? But that's what basically, like if you did that, that's what that means. So this cosine value is squared. Theta is not squared. Theta is theta. Okay? So cosine squared theta plus, I have sine. That's negative 1/3 squared equals 1. I just substituted it into the Pythagorean identity. We good so far? It's just 1. All right, so I do cosine squared theta plus, what's 1/3 negative? Well, negative 1/3 squared is going to be positive, but what's 1/3 squared? Squaring, it's easy. 1/9. You square the numerator, you square the denominator. It's 1/9. That's equal to 1. Then I'm going to have to subtract 1/9 from both sides, which means I want to think about my 1 as 9/9, right? 9/9. So when I subtract 1/9, I get cosine squared theta is equal to 8/9. And then when I take the square root of both sides, and I get cosine of theta, that's going to equal to the square root of 8/9. I can take the square root of the denominator, it's 3. I get the square root of 8 in the numerator. What's the square root of 8 reduced? 2 square root of 2 over 3, and its cosine, since it's in the fourth quadrant, it's positive. So this is cosine theta. Okay. Questions? You gotta be not afraid of the fractions. You gotta be not afraid of the square roots. Okay? But they're not crazy, right? They're just basic stuff that you should be comfortable with. All right, so let's look at, now I gotta find tangent. Well, tangent, well, they gave me sine. I just have to find cosine and tangent. I got tangent squared plus 1 equals secant squared. I have cosine squared, so I could use that to find secant squared. But then, what if this is wrong? That's not going to help me any, right? That's a little scary. But let's use what they gave us. Well, why would, because nobody's perfect, right? Plus, it's not that pretty. So just trust me on this one. Let's look at what they gave us. If you can use what they gave you, that's way better. So sine of theta could be changed into cosecant. So if the sine of theta is negative 1/3, what's cosecant? Negative 3, right? Now, if you had a choice between using cosecant or cosine, which one's prettier? Cosecant for sure. So I want tangent in the end, but I can use this to get cotangent and then find the reciprocal. You with me on that? So we're going to use our cosecant in this Pythagorean identity. So cotangent squared theta plus 1 equals that cosecant, which is negative 3, squared. Everybody with me? So I get cotangent squared theta plus 1 equals 9. So cotangent squared theta equals 8. So cotangent theta equals what? 2 square root of 2. Is it positive or negative? We're in the fourth quadrant, so it is negative, right? I don't want cotangent. I want tangent, right? So how do I find tangent? It's the reciprocal. So the tangent of theta is equal to negative 1 over 2 square root of 2. And then when I rationalize, I get negative what? Multiply this by the square root of 2 over the square root of 2. So I'm going to get square root of 2 over what? 4. There's my answer. Any questions at all? We got it? Okay. Let's look at number 5. So on number 5, I want to find the tangent and the sine given the secant. Secant is positive. Secant is the reciprocal of what? Cosine. And cosine is positive in quadrants 1 and what? 4. All students take calculus. Sine is positive in quadrants 1 and 2. So they overlap in quadrant 1, which means this is in quadrant 1. Everything's positive in quadrant 1. Okay? So we take the square root, we don't have to worry about signs. So I'm given secant. If I look back up here, I'm given secant, and tangent is one of the things I want, and these are both going to be positive. So I can use this identity right here. So I'm going to start with tangent squared x plus 1 equals secant, which is 6/5 squared. That means that tangent squared x plus 1 equals what? 36 over 25. Okay, it's okay. So I need to subtract 1 from both sides. I need to think of that 1 as what? 25 over 25. So this is basically minus 25 over 25, right? So that means that tangent squared x is equal to 11 over 25. So then I take the square root of both sides, and tangent of x is going to equal what? Square root of 11 over 5. And this is positive, right? Because we're all in the first quadrant, and so there is my tangent value. Any questions at this point? All right, so I also need sine, which means cosine would be helpful. I have secant. Secant can get me to cosine, right? So cosine of x would be what? What would cosine of x? 5/6. Okay, good. So then I can use the Pythagorean identity, which is cosine squared, so 5/6 squared plus sine squared x equals 1. So what's 5/6 squared? 25 over 36 plus sine squared x equals 1. So I'm going to have to subtract 25/36 from both sides, which means I want to think of this 1 as 36 over 36. When I subtract 25/36 from both sides, I get that sine squared x equals what? 11 over 36. Then when I take the square root of both sides, the sine of x has to equal square root of 11 over 6. And it's positive because I'm in the first quadrant. It's not that bad. It looks really terrible, but it's really not that bad. I mean, you've got fractions, but it's really, the numbers are doable. It's not crazy hard. Be careful of the signs. Make sure you're paying attention to what quadrant you're in, because that's one thing that can just kill you here. Questions? All right. Let's talk about the next two sets of identities. These cofunction identities. Like you got sine and cosine, secant and cosecant, tangent and cotangent. So we know that like the sine graph, if I just shift it to the right or to the left, I can make a cosine graph, right? That's what this is. This is just your shift, right? Just to make the graphs. So sine is the same thing as cosine of pi halves minus theta. Make sense? You just move over pi halves one way or the other. So this is really just stating that, just like secant and cosecant. Those graphs, you just move them over and they'll match up. Same, that's all that this is. Do you have to memorize these? No, you do not. But honestly, it's the same thing every time. And you know that cosine goes with sine and tangent goes with cotangent. It's really not that hard to come up with, but I'm still not going to make you memorize them. These even-odd identities, okay? This is not a factoring out of a negative sign. If it was, then we wouldn't need these here because you know how to factor. So yes, the sine of negative theta equals negative sine of theta. Not because you were factoring out this negative. That's totally illegal from taking it out from the angle. That's kind of like saying, if I have the square root of -4, can I just take that negative sign, that -1, and factor it out in front of my square root? No, because the square root's an operation. Sine's an operation. I don't get to just take the sign out. Plus, look here. Cosine of negative theta is equal to the cosine of theta. There's no negatives, right? Here's why this works, okay? Because I want you to understand why it works before you get all messed up in that and then confused about everything. If I have, okay, so let's just talk about sine. I want to take the sine inverse of something. So what is the sine inverse of 1/2? What's the sine inverse of 1/2? Pi 6, right? What's the sine inverse of negative 1/2? I guess we didn't even have to do inverse. It's negative pi 6 though, right? So that means that the sine of pi 6 equals 1/2. We agree with that? The sine of negative pi 6 equals negative 1/2. We agree with all that? So if pi 6 is my theta, then do you see that the sine of negative theta is equal to negative sine of theta? So the sine of negative pi 6 is equal to negative sine of pi 6. So it's just 1/2, it's just a negative. right? They're the same things, they're just negative. That's why you get to use the first and the fourth quadrants, okay? Let me ask you about cosine. What's the cosine of pi 6? Square root of 3 over 2. What is the cosine of negative pi 6? Square root of 3 over 2. Because this is still in the, isn't cosine positive in the fourth quadrant? So here, cosine of the negative angle is just equal to cosine of whatever theta is. Because cosine of negative pi 6 is the same thing as cosine of pi 6. Does that make sense to you? Nobody factored out a -1. It's just how the angles work, okay? So cosine and its reciprocal, it just looks like the negative sign disappears. Sine, tangent, and their reciprocals, it looks like you're factoring it out. You'll still have the sheet to look at, but the whole point is I want you to look at it because people are using these wrong, thinking you can just magically like factor out a negative, and that's not what's happening here, okay? It has to do with stuff that looks like this. So let's look at number 6. It says, if the sine of negative theta equals negative 0.97, we want to find the cosine of pi halves minus theta. All right. Well, we know that the cosine of pi halves minus theta equals sine of theta, right? So I need to figure out what sine of theta is. I'm starting here. Sine of negative theta equals negative 0.97. Well, from here, I know that sine of negative theta is equal to negative sine theta. I got that straight from my little reference sheet. You with me? Do we know what sine of negative theta is? Yeah, they gave it to us, right? We have it right here. So I can substitute. So negative 0.97 is equal to negative sine theta. All right, so then what is the sine of theta equal? Equals positive 0.97, right? You see how that works? Basically just multiply both sides by a -1. All right, so then let's just kind of pause right there for a second. And cosine of pi halves minus theta, that's equal to sine theta. I'm getting it from right there. Make sense? Can I substitute now? Look at this. Can I take this and substitute it in right there? So cosine of pi halves minus theta is equal to 0.97. It's all about just using those identities and substituting and not making anything up. Easy enough? That really is pretty easy. So just make sure the signs are what's going to kill you here, just like a lot. That's really one of the worst things that is just torturous to you. You make one sign error and it throws everything off. But we good? You can't skip too many steps on this stuff. You start skipping a bunch of steps, you're going to get yourself confused or you're going to lose a sign somewhere. So you want to be very diligent in your work. Don't stress out 3 steps ahead. I mean, it's good that you can think 3 steps ahead, but make sure you're just writing down what you know how to do at this step, and then you're good to go. Okay? Questions? All right, we are not doing 7 and 8 because questions like that we're also eliminating from the homework. So let me hand out your assignment, and then I will tell you which ones to mark off. All right, so on the assignment, look on the back, and once this will turn its page, we are going to omit 9 and 11. So mark off 9 and 11. Okay? Pay attention to it. Watch your signs on 10 and 12. The rest of these you can do. Actually, there's one more mistake, and let me find where that is. Not all of them. Hang on. To figure out where that was. It was a weird mistake, and let me... I think it might be a different assignment, now that I'm thinking about it. No, you're still doing this one. Yeah, it's a different one, I think. All right, that's it.